Welcome to Brain Vision.
So here in this problem we are given that water issues from this nozzle with exit velocity v, and the density of the water is rho, and it hits on the mass on this block that has mass m. Now if the block is on the verge of tipping rightward, then we have to calculate the minimum coefficient of friction mu between the block and the surface and the expression for the exit velocity v. So these two things we have to calculate. Now, to solve this problem, let me first show the forces acting on the body, and we are taking this block to be as our system. So the force would be acting like this due to the water, and the weight force would be like this, mg, and the normal force by the surface would be n. This is the normal force. Now the friction force would also be acting like this, which is against the motion this way. Let it be F. And here we see that the system is at rest, so we can equate the forces in the y direction and the x direction. So this one is our x direction and this one is our y direction. So we can write that sigma Fy equals to 0. Therefore we can say that n minus mg would be equals to 0, or we can write that n is equals to mg. Similarly, sigma fx would be equals to 0, so we can write that F minus the friction force F would be equals to 0. So F would be equals to the friction force, and friction force we know it's mu times n, and n is mg here, so mu times mg. So we can put it here. This would be equals to mu times mg. Now we can do one thing to calculate the coefficient of friction mu. We can take moment about this point. Let this point be O. So we'll be taking moment about point O. So sigma mo would be equals to 0. So, and the forces in the clockwise direction will be taking positive. That means the forces that is making the clockwise moment will be taking as positive, and in the anti-clockwise direction will be taking negative. So about this point, this force is making clockwise, so it should be positive here. So F times H. Now the mg force is making anti-clockwise, so it should be negative. So minus mg times the perpendicular distance. So this distance would be d over 2. So d by 2, and it will be equals to 0. Now F we know it's mu times mg, so we can plug it here. So it's mu times mg times h minus it would be mg times d over 2, and it will be equals to 0. So from here this mg will cancel it out. It's common, you can cancel it out, and we'll get the expression for mu to be d over 2h. So this is the required expression for the coefficient of friction between the block and the surface. Now next we have to calculate the expression for the velocity v. Now for that let me first calculate the mass flow rate coming out from the nozzle. So m dot is equals to rho times area times the velocity. Now we can use the momentum balance for the system, which is F net is equals to m dash delta v, or you could say m dot delta v. So F net we have the force F, and m dot we have rho times a times v times this delta v. So delta v means final velocity minus the initial velocity. So since the final velocity is like this, so there is no component of the velocity in the perpendicular direction, so this would be v as it is. Change in velocity would be v only, so that would be rho a v square. So this is the expression for the force F, and we know that force F is equals to the friction force F that we derived in the last part. So this would be equals to the density times area times v square, and this was equals to mu mg, and mu we know it is d over 2h. So we can write that rho a v square is equals to d over 2h times mg. So from here, the expression for velocity comes out to be as under root mg times d divided by 2 rho ah. So this is the required expression for the velocity, exit velocity, that was asked in the question. So I hope you have understood the problem. Thank you.